Welcome or welcome back if you came from a different video of mine. It's been a while since I've done a practice problem set for the SAT exam, the math portion of the exam. I think last time I left off on the stats chapter. We were doing like probability and conditional probability, if I remember correctly. The next chapter is on quote unquote advanced algebra of the SAT, which is not really advanced. You learn a lot of this actually traditionally in Algebra 1, and actually a lot of it in pre-algebra, if that's still a thing. It does eventually in the trig sections go up to maybe Algebra 2, not too much there if I remember correctly, but we're on exponents right now. So you gotta know all your properties of exponents basically, which I have many shorts on. Not many, but I have a few shorts on, so you can go check those out if you want a quick refresher on some of the properties and why they work the way they do. Okay, I made them recently as of the filming of this video. But anyway, let's begin. We have number 1 here. If this guy equals k a to the m b to the n, what is the value of m plus n? So go ahead and try this first yourself. You can pause the video and try it. I'm going to start though. So we're interested in a to the m, b to the n because we want m plus n. We don't really care about this a. So let's just find out. If we have a squared times a, that is a cubed, because when you multiply exponents with the same base, you add the exponent value. So it's a to the 2 plus 1, which is a cubed, okay? Similarly, for b, we have b to the 3 plus 2 plus 1, which is b to the 6, okay? So m plus n, that is 3 plus 6, which is 9. That's our answer. All right, number 2, we have this guy. This is pretty much the same type of problem. As you can see, what is the value of k? We're interested in k this time. So go ahead and try this one. We need a property where we distribute this exponent to each of the terms. So for k, we're only interested in the constant, not the a to whatever power, b to whatever power. So let's just worry about 2/3 squared, and we have 4/3 to the minus 3 power. Okay, so let's distribute this to both. That would be 2 squared over 3 squared times 4 to the minus 3 times 3 to the minus 3 on the bottom, like this. Now we can use properties again. 3 squared times 3 to the negative 3. We add the powers. That is 3 to the negative 1. Okay? This is, 2 squared times, 4 is 2 squared as well. So I can write it like that. And properties of exponents again. Multiply these two numbers together. That is 2 squared times 2 to the minus 6 over 3 to the minus 1. This is 2 to the minus 4 because 2 minus 6. Okay, negative exponents, we can flip them and make them positive. So it'll be 3 over 16. 2 to the 4th is 16. That's our answer. Okay, so as you can see, you have to be fluent in your properties of exponents here. All right. Number 3, we have this guy equals x to m, y over y to n, z to the p. What is the value? M plus n plus p. Okay. So, what do we have here? We have x cubed divided by x to the minus 2. When we divide, we can subtract the powers. So 3 minus negative 2, so it's x to the 5th, okay? Minus 1 squared, we distribute this squared to both the negative 1 and the y. So negative 1 squared is 1. And then we have y squared on top and a y cubed on the bottom. So y squared divided by y cubed, that is y on the bottom. Y to the first power, even say. Okay? Z to the minus 2 divided by z, that's z to the minus 2 minus 1 power. That's z to the minus 3, which is z cubed on the bottom. And this exactly matches this form, right? So m plus n plus p is 5 plus 1 plus 3, which is 9 again. Okay. 2 to the x is 5. What is the value? 2 to the x plus 2 to the 2x plus 2 to the 3x. So go ahead and try this one. So it might seem complicated, but it's actually really not. Okay, we're going to use properties of exponents again. 2 to the x plus 2 to the 2x, you can rewrite as 2 to the x squared, because you have that property where you can multiply this 2 to the x, right? And similarly, this is 2 to the x cubed, this last one. Okay? Now, how does this help us? Well, we know 2 to the x is 5, so let's substitute 5 plus 5 squared plus 5 cubed. What is that? That's 5 plus 25 plus 125, which is 155, if I did it in my head correctly. Okay. Next, this one looks similar. 3 to x plus 3 to x plus 3 to x, all multiplied by 3 to x, which the following is equivalent to the expression shown above. Okay. Well, 3 of the same thing is the same thing as 3 times 3 to the x times another 3 to the x. Okay? This is 3 to the first power, right? So we can use properties of exponents again. 3 to the x plus 1 times 3 to the x. Okay? They're being multiplied, so I can add the powers. And then again, these are being multiplied, I can add the powers. 3 to the 2x plus 1. Answer is D. And the expression above is written in the form, the sky, what is the value of m plus n? Okay, we got to be careful with simplifying, so let's begin. Okay, so this would be a 4 on the bottom, right? And then this would be a 3 and a 2, like that, right? Okay, okay. Actually, no. See, I already made a mistake, because this is a 4. So, okay, so let's restart. Let's distribute the square to each first. Okay, 6xy squared times 4x squared y squared over 8x squared y squared. Okay, so be careful. I almost made a mistake. Okay, now let's start simplifying. This would cancel with that. This would cancel with that. Okay, this would be a 2 on the bottom, and this would be 3xy squared. Okay, that's what it would simplify to. M plus n, that is 1 plus 2, which is 3. Okay? Be careful. I almost made a mistake. If x is not equal to 0, what is the value of this guy? So it looks like we got to simplify. So let's distribute this square to each of those first. So that, and this cube to each of these. So that would be 8x cubed times 3x over 36x to the 4th. Okay, properties of exponents again. All right, now x to the 4th, those would cancel, right? And then we have 24 over 36, which is, what is that? That is, it can go into 4, right? Or even, yeah, 4, so that would be 9, and that would be 6, which would be 2/3, if I did it correctly. Yes. Okay. This one's about scientific notation, it looks like. If 8,200 times 300,000 is equal to this guy, what is the value of n? Okay. Well, if you're not allowed a calculator, how would you do this? What's 82 times 3? That we can quickly do it on the side if we really needed to. 82 times 3. That is what, 246, right? So it'll be 246. And then how many zeros do we have? We have 1, 2, 3, 4, 5, 6, 7. Did I count right? 5, 6, 7. Times 10 to the 7th. Okay. Now, in scientific notation, well, they already gave us the form. We got to move 2 more decimal places. So it'll be 2.46 times 10 squared times 10 to the 7th, right? This is by 100. So I would move the decimal twice, and I get back that. And that is 2.46 times 10 to the 9th. Properties of exponents again. So our n is 9. 9 seems to be a common answer in this section. All right, next and last. This guy is equal to 1 over 5 times 10 to n. What is the value of n? Okay. Well, let's get rid of some zeros first. So 3 zeros would go away. Okay. 1 0 would go away. Okay. So what do we have left? 24 over 72 times 10 to the 1, 2, 3, 4, 5, 10 to the 5th, right? So this would be 3 and 9, right? And this would be 1, and that would be, did I do this right? It should be a 5. Got rid of 3 zeros, 1 more 0, 24, 72. That's right. Okay, so see, I'm checking my work now. I might have did something wrong. So, oh, there's still that 6 there. Did I not take that into account? Okay, so the zeros got canceled correctly, it looks like. So 24 times 6 over 8 times 9 times 10 to the 5th. Okay, because I think I forgot that 6, that might be why. So then, let's start canceling. This would be 3, and this would be a 2. This would be a 1. This would be a 3. Two over, did I do this right? 10 to the 5th. 2 over 10 to the 5th. I think this is right. Okay, let's continue. But it needs to be 1 over 5 times 10 to n. Well, actually, I can rewrite this as 1/5 times 10 to the minus n. Can I not do that? It's the same thing. Okay, so I know that 2 over 10 times 1 over 10 to the 4th, 2/10 is a 5th. Okay, so n is 4 then. Okay, so I pieced it together. Yep, that's right. Okay. So this is probably a more quote-unquote advanced one. See, even I took a little while to think about it. So start canceling the zeros first is my tip. Okay? And then you start simplifying. I got 2 over 10 to the 5th, but this is the answer. Did I do something wrong? I then started thinking, well, 2 over 10 is 1/5. And then this I can technically rewrite as 10 to the minus. And this helped me to think that to break it up like this exactly. If I rewrite this guy in this form, this helps me think to break it up like this problem solving skills. And then 2 to the 10th is 1/5. And then therefore, my n is 4. Hopefully that made sense. Okay, this is one way to do it. I'm sure there's other ways to do this, but this is how I thought of it live on video as you saw. Okay, so that's it for this section. This practice set. Hopefully you got something out of it. Please like and subscribe as always if you found this helpful.